Hello. So in the last lecture, we studied about B plus tree and B tree. So as we have seen, B tree and B plus tree is like very good when it comes to range queries, or also it is fast, right? So now in this lecture, we will learn about LSM trees. So this is an example of an LSM tree. What is LSM tree? So LSM tree is created by red black tree or ABL tree or any kind of binary search tree. But what is the problem with this? So the search in this LSM tree is in log n. Okay. So what are the problems of LSM tree? First, it is in memory. Okay. And the second is no durability. So this LSM tree stays inside RAM. Okay. It doesn't stays inside uh, hard disk. So it is not durable also, right? So the first problem is uh, no durability because it is in memory. Okay, so because of that, what we do, we keep a write ahead log. Okay, what is this write ahead log? So when we are going to make any changes inside our LSM tree, what we do, we create a log that can be in text file or any file which is kept in the hard disk. Okay, so even if the power goes down, we can refer to this write ahead log and create the tree again. Okay, so that is the first thing. And the second problem is, as it is in memory, the amount of memory inside RAM is like limited, right? That's why it's the second problem is it's in memory, due to which the space is not like infinite like we have in hard disk. So how can we tackle that? So there is a concept told as SSTable. Okay. So what happens, like for example, this is your LSM tree. Okay. So let's say once the length increases more than uh, let's say once the length increases more than 3, the height increases more than 3, we write the whole thing in an SS table. Okay, and we dump the whole thing in SS table and make a new tree. So whenever we are creating a whenever we are inserting a new data, we insert, and once the LSM tree is filled, we put it inside hard disk. We push everything inside the hard disk and create a new tree. So benefits of this: first, as the starting whenever we are searching the data, first we search inside the RAM. If we don't find it, then we search inside the SS tables. Okay, so the benefit of is this is the recently written data is inside RAM, due to which the read is very fast. Okay, and the write is also very fast. And in case of like SSD, like we know the number of writes inside SSD is very limited. So in one part of SSD, you can only write like, let's say, 1000 times or 2000 times. Okay, so changing the value, let's say this is 500 bits. Okay, and here you only want to edit or update 1 bit. Okay, so every time making changes for 1 bit, the whole the life of the SSD actually decreases. Okay, due to which what we do, like we store it in a LSM kind of tree, and after some time we flush that inside the SSD once the whole tree is filled. So by that, the speed is also fast, and the second thing is like the life of SSD is also fast. I'm not only talking about hard disk, I'm also talking about SSD over here. Okay, so yeah, this is what LSM tree is. And if we don't when we read, if we don't find in the LSM tree, we go to this SS table and find out the difference. Okay, thank you.